go. Okay, so the optimization questions that we're going to do today can take a lot of time, and so I wanted to make sure I got all of that in first. Worst case scenario, tomorrow is just kind of a day for going over questions and everything, like the kind of review day somewhat. So if we don't get time to it today, I can either help you in open help, after class, or I can help you tomorrow too. So just kind of whenever works. Okay, I've had the first question up on the screen for a while, so I'm going to guess you guys have it written down by now. Optimization is just kind of the generic heading for this section. But the optimization itself is just kind of a singular word saying max or min in a word problem. It's basically finding extrema, but when it's in a word problem, they refer to it as optimization. Okay, so this first question here. It says a manufacturer wants to design an open-top box with a square base and a surface area of 108 square inches. What dimensions will produce a box of maximum volume? So this is, this exact situation, probably doesn't happen, but this style question does. So, let's say a company has a sheet of cardboard, and from that single sheet of cardboard, so the surface area, they want to make the biggest possible box they could because, it's just basically being able to fit more things would be cheaper for them to ship. So, this type of situation is normal. Like, you want to optimize situations. So I guess what I'll start with first is I'll probably just draw a little picture here. So we've got a square base and open top. I'm not the greatest drawer, but I'll do my best. Okay, so the open top box part itself kind of means that you can see the inside from the top. I don't know if that helps or not. That kind of just makes it look like I shaded the top piece, doesn't it? Let's erase that. Let me do the exact opposite. I probably don't have a good way of shading this. I wonder if I go like this. That might make it appear, I don't know, who knows. So just kind of pretend this is like a shoebox without a top, right? But we do know the surface area is 108 square inches. So what we're going to do is we generally kind of break this up into two different kinds of equations. So you're going to have a primary equation and the primary equation is what we're trying to minimize or maximize. And then you're going to have a secondary equation. And the sole purpose of the secondary equation is to help you find the answer to the primary. So the secondary equation traditionally has like numbers in it that you're going to be able to use to substitute. It doesn't have to have numbers. It doesn't have to have numbers, but the sole purpose of the secondary is what you're going to use to substitute. Now, it's far easier to determine the primary equation. Okay? Basically, the rest of the information is secondary. Primary equation is always going to be what you're trying to maximize or minimize. Now this one's very direct, right? It says maximum volume in the problem, so like it's super obvious what we're trying to. Let's see what hider is this going to highlight it? Oh, you can't even. You just see the words. Well, I see the word maximum volume, so then that's kind of clear to me that that's what I'm trying to maximize, right? So under primary equation, I'm going to put volume because I want a maximum volume. If it helps you, you can write it right there to help remind you. Okay, well, now I need variables. So I'm trying to find the volume of this open top box, which normally would be length, width, height. They specifically made this problem easier for us, so it wasn't 3 variables. Because in the problem, it specifically said a square base. So a square base would mean these 2 sides are the same. The height of the box could be different, probably is different, but we'll find out. We just know that the 2 sides on the bottom are the same. So the volume of this box would be side times height. Jessica, totally unrelated to this problem, but will be related. How do we find max and min information again? And I guess I totally... Perfect. Perfect. Our first derivative test is kind of what we used to figure out max and min. So that's what I want to do on this problem. Now, if I were to take the derivative, so prime, the way this problem is currently set up, I'd have to do the product rule on 2 different variables. So I would have to do implicit differentiation. And I could if I wanted to. But these problems are set up so that the secondary equation will help us make the primary equation easier to focus on. So my goal is to do derivative because that's how I find max and min. Secondary equation, basically what's the other sentence in the problem that has information? So in this one, it says surface area of 108. That's the only other piece of information in this problem. So surface area is 108. Well, surface area is basically some sort of a formula depending on the shape. Well, this box would have 5 sides. You'd have the 4 sides around, all around it. Those would all be identical size because they're all S by H. So we would have 4SH, and then we have a 5th side on the bottom, which would be S by S. Now, once you get your secondary equation, it is completely up to you how you want to substitute it. You basically can solve for S or H. It usually doesn't matter. Of an open top box with a square base. So that's surface area of this picture. Yep. If you want to set it up more generic, you certainly could. Yep. I find the area of all the sides of the shape. So like the area of this side of the box is S by H. So that was side 1. Side 2 is also S by H. Side 3, S by H, S by H. So all 4 sides are S by H, so that's the 4SH. And then the bottom is S by S, so that's S squared. So on this particular problem, though, it's much easier to solve for H than it is for S. So I'm going to solve for H. I would do that by subtracting S squared and then dividing by 4S. Now, it's kind of up to you if you want to simplify it or not. It's just, it's kind of personal preference, to be honest. I would prefer to simplify this, but you don't have to. And honestly, it doesn't matter when you simplify it. So maybe I'll substitute first. So now that I've figured out H is equal to this, I'm going to put this in place of H so that my primary equation is only one variable. All of the optimization questions you guys are going to get will be able to be done in one variable. I'm not going to give you an optimization that has to be, well, I shouldn't even say that. They'll all be solvable. So even if it's not one variable, you'll have information to be able to solve everything. So S squared times 108 minus S squared over 4S. And I'll simplify this before I do derivative because otherwise this would be a nightmare. It looks like I can cancel an S. So I have 108S minus S cubed over 4. And I can divide both of them by 4 to make it polynomial. (108) divided by 4 is 26. So I'd have 26S minus, this is like saying 1 divided by 4. So I would have 1/4 S cubed. How are we doing on that? Does anybody want me to talk? Oh, go ahead. Yes, it is. Good call. I like that an eraser makes it look like I did nothing wrong. I know it's recorded on a video, but we'll say that that was doctored. How about anything else that's up there? Are you guys okay or have questions on setup of the problem? So I don't want you to get too focused on the fact that we're doing a box, and that's why I'm trying to emphasize primary equation that's maximizing, minimizing, secondary equation, because every one of these problems is totally different. Okay, and I think I called on Jessica before. She told me to be able to find maximum, we look at derivatives. So I'm going to take the derivative. Would it be 27 minus 3/4 S squared. So 3 times 1/4 S squared. Okay, and then Ari, our resident expert, is going to remind us how to find critical numbers, because we need critical numbers because that's where maxes and mins happen at. Nice. See how much better you remember that today than yesterday coming back after a super long vacation? Nice. Okay, underneath the picture, I wrote some constraints on here. So some of the problems you guys are going to get will have a set domain. Some of them won't. On this one, our original problem said the surface area could only be 108 square inches. So I'm working with S right now. The smallest S can be is basically right above 0. Because if S was 0, you wouldn't have a box. The biggest S would be square root of 108, because then all 108 square inches would be the bottom piece, which also wouldn't make a box. So S has to be in between those two numbers. So technically we're going to use that as our domain, but none of these problems you're going to get, you'll have information that won't make sense. Okay, so I'm going to set this equal to 0 or undefined. So 27 equals 3/4 S cubed squared, not cubed. I'm going to multiply both sides by 4/3. And then I'm going to take the square root. And I get plus or minus 6. This is kind of why I was bringing up the domain. Negative numbers just flat out don't make sense because we're talking about the length of a side. So S equals 6 is our possible max or min. Well, it has to be bigger than 0 because it has to be positive. And 108 square inches is the size of the whole piece of cardboard. So the biggest this could be is square root of 108, because then the bottom piece would be all 108. All right. Now, critical numbers, we don't know if it's max or min, so we have to figure it out. We have two ways of doing this. One way is to make the table and check for increasing, decreasing before and after. And you 100% could do that because we have the derivative right here. The second method is to find the second derivative and figure out the concavity at 6. Because if it's concave up, it's a minimum. If it's concave down, it's a maximum. I'm going to do the second derivative because on this problem that's less work. Second derivative would be 27 minus 3/4 S. And I want to find the second derivative at 6 because that's my critical number, which would be 18/4, which would be 4.5, which is a positive answer. Oh, it's not 3/4 S. Oh. I took the derivative. Wow, I was looking at the wrong equation. You know, this was a great example to show you guys of human error. Yes. You know what? I'm kind of mad at myself today. I'm going to highlight this so that I don't look at the wrong equation again. I was looking at Vmax. Derivative of 27 is definitely 0. Derivative of negative 3/4 S squared is negative 6/4 S. And that would give me a negative answer, which would mean concave down, which is good because I knew it was supposed to be that. Concave down at a critical number tells me that that is a max. Okay, now before this is where it's really easy to also make mistakes. I got an answer and so I'm like done. Every question usually asks you something different. And so like the answer I just found isn't necessarily what I'm trying to answer for the problem. What dimensions will produce a box of maximum volume? So I need all three dimensions. So I just figured out that S is 6, gives me a max volume. So then my box is going to be 6 by 6. And then I need the height. Let's just go with somebody, random somebody. Kelly, how do I figure out the height? I figured out the side length. How do I figure out the height? Yeah. So when you're doing the substitution, traditionally the substitution is what you used to take away this variable. So this one that I have circled is an equation to find the height already. And that's how these optimization ones usually are set up. So 108 minus 6 squared divided by 4 times 6. 72 divided by 24 would be 3. So maximum volume would be 6 by 6 by 3. And you definitely can see why these problems are going to go slow. Like, we don't have any new calc info in this. It's just kind of using the calc stuff we've learned so far. But a lot of people don't like these because you're not explicitly told what to do. Like, you have to figure out the shape, you have to figure out the equations. So that's why definitely a lot of people don't like them. But we got to do them. Anything you guys want me to talk about this problem? I'm hoping this isn't a case of you're so confused that you just don't even know what to ask. Because I kind of figured I would have gotten a lot of questions. I'm really glad you guys are on top of your game, watching out for errors on my part, though. Do you want me to move on? I certainly can. Okay. Here's a completely different style question. I'll give you a minute or two to write it down. And then we'll talk about what it means. Let's see, 12. Yeah, we might have time at the end. Okay, side note. This is always my favorite lesson of the year when we were working out of the textbook. Because the textbook, like an ebook, it has a stupid thumbnail, like just a normal little thumbnail clip for this problem, where it shows you a piece of paper with writing in the middle. And the reason it's my favorite is because for whatever reason, I zoomed in on this problem. And then I realized that this little tiny half-inch by half-inch thumbnail that was in the textbook was actually a real paper that somebody wrote 40 years ago that they put as a thumbnail and then they shrunk down. So when you zoomed in, you could actually read the paper. I think it was about Newton. So somebody wrote a calc paper. Okay, so this whole problem is just basically a regular piece of paper. I mean, it's not 8.5 by 11. It's just a piece of paper. And on the piece of paper, the amount of wording that needs to be printed is going to take up 24 square inches of print. So that's kind of what the 24 square inches is talking about. That's how much actual like ink or toner would need to be used to print out these words. Now, this paper is supposed to have margins on it. So top and bottom margins are supposed to be 1.5 inches, and left and right are supposed to be 1 inch. I know that looks like an L or something, but that says 1 inch. It says what should be the dimensions of the piece of paper so that the least amount of paper is used. So I drew a terrible picture of a piece of paper with print on it. This problem is trying to say that this print is 24 square inches. Oh, certainly I can scroll back up. It's the downside to word problems, just writing them down. How about right here? Can I scroll this far? Perfect. Okay, so this takes up 24 square inches. We're also told that you're going to have 1.5 inches on the top, 1.5 inches on the bottom, 1 inch on the left and right. Now, I mean, that kind of drastically matters because the whole point of this problem is to find out how many inches wide and tall the paper should be, the dimensions. So the margins affect that. Now, we can set this up different ways. But the big thing we need to figure out, let's go with Michael. Michael, what are we trying to optimize? Should we start with, are we trying to find a maximum or a minimum? Let's see, it's Michael, he's in the classroom, so maybe this was a bad move. Minimum, okay, good. We are trying to find a minimum. In the problem, it does not directly say max or min, because it's not always going to. On this one, it says least amount of paper. So that's just kind of inferring minimum. You're trying to find the minimum amount of paper. So our primary equation is going to be the paper. Our secondary equation is traditionally the rest of the problem that has numbers in it. I mean, it doesn't have to be, but that's often what it will be because you traditionally will need numbers to be able to substitute. So secondary equation, the only other thing that's talked about in the problem is the ink, the actual print, right? So the area of the print is our secondary equation. And we know the area of the print is 24 square inches. Now here's where we kind of have options. Oh, go for it. Say it again. Yes, because the least amount of paper would be the smallest actual paper size, which would be area. Just that's what the amount means. Like when it says least amount of paper, the amount of paper is no. If it was referencing volume, it could say the amount of volume, but I'm trying to think of how to explain it with This is where it would really pay to be an English teacher. Yeah, I know. I mean, I always like to give, definitive things. This one, it's almost just like it's inferred. The wording of the problem, the least amount of paper is just kind of basically telling you the smallest area. Well, that'll give you both dimensions, correct. So 2-dimensional would be area. Sure, that's a good way of explaining it. That was a nice one. I was trying to think of a good way of saying 2-dimensional in the problem, but the you know what, if I would have said 2 dimensions out loud. The word dimensions means we're trying to find both numbers, so that would be 2-dimensional area. Okay, anyway, here's what I was trying to get to. We have to decide what the variables are going to be and what they stand for. This problem can be done 2 ways. So our variables are obviously in some way or form going to be base and height. What we have to decide is what's going to be considered the base and what's going to be considered the height. Do we want to make the print base and height, or do we want to make the paper base and height? Now the problem works both ways. It looks 100% backwards because the information is set up backwards, but just letting you know that you'll have to decide that sometimes. So just because I drew these orange lines first, I'm going to decide that's base and this is height. So my secondary equation is b times h equals 24. And to me, I made that easier because it's easier to substitute. But it's kind of personal preference. Well, if this is b, how come the paper is b plus 2 and h plus 3? Caduce? How come the bottom is b plus 2? How come the paper is 2 inches wider than the print? Oh, wait. Yeah, he's in the classroom too. Great. Let me just scroll down farther on the name list. Let's go with Natalie. Natalie, your internet's probably going good because you're at home. How come the paper is 2 inches wider than the print? That's what the plus 2 means. That's it. That's perfect. So if I'm looking at this printed area, I've got an extra inch here and an extra inch here, so the width would be 2 inches more. And if I'm looking at the height, I've got 1.5 inches here and 1.5 inches here, so the height of the paper would be 3 extra inches. That's no problem, Caduce. Pretty much everything bugs out when you're in the school because you got so many people trying to use the internet. So these would be the dimensions of the paper. So when I'm writing my primary equation, I would write b plus 2, h plus 3. If I had decided that the paper was b and h, then the print would be b minus 2, h minus 3. And this problem still works either way. No matter how you set it up, it's generally going to be harder in one place, easier in another. Okay, so I've got my paper, but I want to put it in one variable, so I decide over here which one I'm going to solve for. It 100% does not matter. Let's just make it h equals 24 over b. So now I have b plus 2 times 24 over b plus 3. Wait, I'm scrolling on the wrong name list. I need to pick people who are not in school. Kayla. Kayla's at home. Kayla, what would you do next? Because we have a lot of different things we could do next. Okay, we definitely can do that. If you wanted to do derivative right here, you could have as well, just a little bit harder. So I would do the same as you, where I would probably simplify this first. So I'm going to FOIL it. So b times 24 over b is 24. b times 3. 2 times 24 over b would be 48b to the negative 1. 2 times 3 would be 6. But instead of writing plus 6 at the end, I'm going to put these two together to make 30, because they are both regular numbers. Okay, so I've got 30 plus 3b plus 48b negative 1. Vincent, what about you? How should we do this next? We are trying to find a minimum. I thought I remembered you saying you fixed your microphone. Oh. He had to be let in again. Oh my gosh. Probably. I honestly don't even remember this test off the top of my head. Probably free response, because we usually want to prepare you for the AP test, which has multiple choice and free response. So Vincent, I just called on you even though you weren't here. That was super nice of me. Dylan, how about you? What? Where did Dylan go? Okay, this is going great. Jack. All right, perfect. We got a response. What would you do next? Perfect. So our goal on getting the minimum would be from the derivative. So a prime would be 0 plus 3 minus 48b to the negative 2. Now we need to look for when the derivative is equal to 0 or undefined. Well, right away I know that I have an undefined value at 0. Emma, why don't I care about b equal to 0? This worked so much better when it was just distance learning. Ellie Moss, how about you? Why do I not care about b equal to 0? True. So b equals 0 is an undefined value of the derivative. But when I get to the end of the problem, b equals 0 is a ridiculous answer because correct. A base of 0 would mean your print is 0 inches wide and infinite inches tall. Correct. So we do have an undefined critical number, but we're not going to use it because it doesn't make sense. So I'm going to solve for b. I'm going to multiply by b squared, divide by 3. I'd get 16. So I'd get plus and minus 4. Again, I'm going to throw out 4. Or, excuse me, throw out negative 4 because a negative base is just as bad as saying 0. So a base of 4 is right now my only logical choice for a maximum or minimum. And I want to go about figuring out, is this a max or a min? Now, technically, we have to prove this, but you guys are going to be given questions that this only works for, right? Like, if you only have one possible answer, it's going to work. We might end up with multiple critical numbers, and in that case, then you have to figure out stuff. But, like, if we only have one possible answer, and we're looking for a minimum, it's not going to turn out to be a maximum. But we have to prove it. So I either have to do the first derivative test on A prime, or I have to do second derivative test with a critical number. So I'm going to take second derivative just because that's my preference. And I would get 96 b to the negative 3. And if I put 4 in there, I would get a positive answer. I don't even care what number it is. It's positive. That means this is concave up, which means that 4 is a minimum. And now that I figured out 4 is a minimum, I know that my base should be 4. You know what? I should call in somebody for the next part. Dane, what should I answer for this question? Oh, what does 4 stand for? So I should just answer 4. No. Okay. I did like that you actually went back to the problem to try to figure out what to answer for the question, because that's definitely what you need to do. So we need to figure out the least amount of paper be used, the actual dimensions. Dane, if I look at my picture, that's what we want, yes. We don't know if it's a max or min until we test it. But it'll always work out. Dane, if I look at my picture, what variables up there stand for the size of the paper? Close. So H and B represent the size of the print. So what I just found out, I found out B is 4, would be the smallest size paper. So I'm going to have to use B plus 2 and H plus 3 to answer this question. So the paper itself is going to be 6 inches wide. The height of the paper I got from over here. The height of the paper is 24 divided by my base, which was 4, which is 6. So the height of my piece of paper would be H plus 3, or 9 inches. So that piece of paper would give me minimum area. I mean, like, absolutely anybody else. Just, I mean, I'd like you to feel free to ask questions if you're having them. I know you guys are hesitant to ask questions at the time because you don't want to appear like you don't know what's going on. But I can just tell you, everybody's in the same boat as you. I know you guys have questions, and I'm shocked people aren't asking a lot more. I've taught this class and this lesson a lot of times, and I know you have questions on this. Why is H6? So, ooh, I almost accidentally picked up the regular pencil. So when we first started this problem, the the secondary information was like the printed part, and we knew that the base times the height of the printed part would be 24. So what we found out that the base of the printed part was 4. So the height of the printed part is 24 divided by 4. And then the paper itself, we have to add the margins on. Do you guys feel ready to try one on your own? Even if you don't, I think it might be good for you to try it. Just because you have to do them on your own anyway. So I took one out of Khan Academy. And this is why I was trying to say that these optimization questions are all flat out very different. This one's not really even a word problem. How about maybe what I should do is I should help you guys get started on the equations. So I'll let you write the problem down first. I'll help you with the equations on this one to start with, and then let you see if you can finish it. Does anybody know what happened to Dylan? He was here at the beginning. I don't think he's in the classroom. No, he's not in the classroom today. Okay, now this one should be semi-clear what you're being asked to maximize or minimize. I mean, it very much straightforward, just says, what is the area largest triangle? So we're trying to maximize the area. Well, now if I'm looking at this triangle, area of any triangle is 1/2 base times height. This problem is on a coordinate axis. And over on the side, we have the point x, f of x. X would be how far it is from the y-axis over to the x point. So the base of my triangle is 2x. And then the height of my triangle would be this, which is f of x. How are we at that? Maybe I didn't even give you enough time to write the problem down. Does anybody have questions why it's 2x? I mean, like, this is kind of what I need you guys to ask if you're not sure where something comes from. Because to be able to do it on your own, you have to be able to kind of go through the same thought process. Okay, the secondary equation on this problem is where I have had a lot of students have issues figuring out the secondary equation. Well, here's what I would do to at least help myself. Right now we have two variables. We have x and f of x, because that's actually a variable. f of x is like saying y. I mean, if it helps you to write y, you can write y. What would our secondary equation be? I'll ask anybody here. What would our secondary equation be? Like, what equation tells me how to exchange these two pieces of information? The top function. Perfect. The one that's written up on top is the only thing there that specifically tells you how f of x and x are related. F of x is always going to be 9 minus x squared. So this is set up right away as our substitution. We're going to put 9 minus x squared in place of f of x. So I'm going to have, you know what? I like how I almost started doing the problem. I wanted you guys to try this one on your own. And I almost totally forgot I was going to do that. Why don't you guys see if you can finish this problem and figure out the area of the largest triangle that fits within that function. I don't know. 3 minutes? Hopefully that's enough time. You know what I'm really good at doing? I'm really good at telling you how long to do something for, and then me not looking at the clock when I told you that. So I have zero idea how long you've been working on this. Do you guys need more time? I'll just ask that. I will give you more time. And I will actually look at the clock right now. It's 1:08. I will give you 2 more minutes, and then we'll get started. Okay. Even if you're not done, that's okay. I'll kind of get started on it because we still have one more problem that I wanted to go through. All right, so the primary equation, you don't have to, but I'll definitely simplify it first. So the half times the 2 would turn out to 1. So then I would take x times 9 minus x squared, and I'd get 9x minus x cubed. That's a good question. If they don't give you units, you absolutely can put units squared after the answer if you want. Otherwise, if they don't give you units, you pretty much can just leave all that off usually. But I like to do the same as you. I usually just write units squared just kind of be safe. But yes, that happens frequently, especially when there's a function involved, like on a coordinate axis. They usually won't give units when it's on a coordinate axis. So my area is 9x minus x cubed. So what this is telling me is whatever x value I plug in, like say x equals 1. Say x equals 1 is right here. The triangle that makes would have an area of 9 times 1 minus 1 cubed. That's what this function is telling us. So we're going to use that function to find the smallest area. Largest area. Derivative next to find critical numbers. So that would be 9 minus 3x squared. And to find critical numbers, it's when this derivative is equal to 0 or undefined. There are no undefined values. This one does technically have a constraint for x's, though. I guess I didn't think about this at the beginning of the problem. But this, it does say at the beginning. It even says right there. I was going to say it had to make the triangle above the x-axis, just kind of the way the problem is set up. Okay, so I need to solve this, and it looks like we're going to get an answer that's not horribly great, and it would be plus or minus square root of 3 for x, but we can't use the minus because that's not between 0 and 3. So x is square root of 3, and we want to verify that's a maximum volume. So to verify that, we either do the first derivative test, or we plug this number into the second derivative. If you guys like doing the first derivative test with increasing, decreasing, you absolutely can keep doing that. I like this method just because it's usually much faster, because all you do is just plug one number in rather than plugging in multiple numbers and coming up with the answer. So derivative of 9 would be 0. Derivative of negative 3x squared would be negative 6x to the first. A double prime of square root of 3 would be a negative answer. So this would be concave down. And that would automatically make square root of 3 a max. Okay, then we go back to the original question. What is the area of the largest triangle that satisfies the stated conditions? Well, square root of 3 is the x value, but nothing to do with the area. So if I want to find the area of this triangle, I actually could take my area equation right here, because that specifically is for finding the area with x values, and then I would find the area equation with square root of 3. And that would give me 9 square root of 3 minus square root of 3 cubed. Square root of 3 cubed would be 3 root 3. So my area would be 6 root 3. And that would be my final answer, that is the area of the largest triangle in this situation. Which is obviously a weird area, but that doesn't matter. How did we do on that? I wish there was a nice easy way I could just quickly check how many people got the answer right. Oh, you know what? I need to change that. That is the alarm for the old scheduled help session time after lunch. How about this? Can you guys give me a 0 to 5 in the chat on how you are currently feeling about optimization questions? Okay. I like it, Joe. So and honestly, I kind of expected the answers to be all over the place, because that's usually where it is. Usually the people that dislike word problems dislike these, because it's just combining derivatives and everything we've done this whole unit along with word problems. And the only way to get better at them is to practice, which is the downside. But so I have one more left that is worked out. So rather than taking a full 20 minutes, I thought I would do, this one was taken right out of Khan Academy. So somebody had this question in their homework last hex semester, and they, let me see if I can make it a little bit bigger. So I can kind of guarantee you're going to run into one like this. Oh, why did I put a 3 next to the 9? Let me go back up. Which 3 are we talking about? The one in pink? Caduce? Are we talking about 9 root 3? Why did I put a root 3 next to the 9? Yes. So, oh, I didn't put it in the secondary equation. Over here on the left, this represented the area of the triangle, because that's what I was trying to maximize. And so I took this area equation once I found out that x was root 3, and I put root 3 in place of x into the area equation. Yeah. Okay, this is a little bit bigger, and I know it's kind of pixelated. But I can almost guarantee you're going to run into a question like this, because every time I've run through the situations on homework questions, usually it's been one like this. So it says the function f is defined as f of x equals x squared minus 1. So not horrible equation, right? What is the x-coordinate of the point on the function's graph that is closest to the origin? Now, the portion of this problem is that there's a lot of things inferred. You're just basically supposed to know all this. So the word closest is what is telling you a lot of things. I don't know who I haven't called on. Alyssa? What does the word closest mean to you? Let's start with, is that max or min? I wonder if your mic is not working right. I saw it, yeah, I saw it move, but nothing was, like, the icon showed you were talking, but it didn't actually work. No, I can't. That's okay. I could tell you were talking because the icon was showing that, but it just wasn't actually talking. So the word closest is going to refer to minimum. Does anybody know what we're trying to find the minimum of? So the word closest is the key word. What are we trying to find a minimum of? This is for anybody. You can either say it aloud or type it in. I was hoping somebody would know this answer. Minimum what? Perfect. So the word closest is 100% inferring minimum distance. And so that, oh, go ahead. Say it again. if we set it up that way. Closest distance would be closest between 2 points. So that would be x and y values, but we can make the equation be just x values. Oh yeah, I see Ellie put that there too. So we're going to set it up that way, correct. But this problem was confusing to a lot of people just because it doesn't like give you any indication of what to do. Sorry, it's really hard for me to hear you guys sometimes. They're apparently doing construction outside my window today, which is awesome. Okay, so I'm going to scroll down, and I've got the whole problem written out. Oh, I erased it. I guess we are going to redo this problem really quickly. I thought I had just left it up there, and I was going to let you guys copy it down. Okay, well, so first thing I do is I write out the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. And x1, y1 is 0, 0. So I can put in 0, 0. x2, y2, well, it's just a random xy point. So I put in x and y. My secondary equation is telling me how to substitute x's and y's. So it would be the y equals x squared minus 1. Now here on the left, I don't know if that's written way too small or sloppy for you to read. When we're trying to find the minimum distance, we're trying to find out the smallest number on the inside of the square root. Julia, I got the secondary equation in the very beginning of the problem. It told me the y is equal to x squared minus 1. Or it said f of x, sorry. But it said f of x equals x squared minus 1. So that's where the secondary came from. So for minimizing, we want the smallest number in the square root. So I actually don't care about the square root. Root over second d. Oh, no, that's what I'm trying to say, Nick. So I took the root symbol off because I want this answer to be the smallest. And without the root, my derivatives and everything are going to be a million times easier. The root portion of the square root is basically just finding the smallest numbers between them. So I'm going to focus on just the inside of the square root. That's kind of what it says over here on the left, which is written sloppily. So I didn't forget it. I did leave it off on purpose. And then I'm going to substitute x squared minus 1 in place of y. And then this information represents the distance between the 2 points that would go in the square root. If I want to find the actual distance, then I'm going to put the number into the square root at the end. You could do that, Mandy. You could just square both sides and make this d squared. I'm basically just not focused on that part. What I'm doing is I'm focusing on just the information on the inside. So just the radicand information. Maybe I'll call this alternate distance so that we're not trying to say it's the same thing. Because I think that's what you're trying to say, Mandy, is this distance that I'm writing here isn't the same as that d. This is just the inside information. I don't need to simplify it. I'll just leave this as is. I'm just going to do the derivative from here. So 2x, the derivative of x squared minus 1 squared would be 2 x squared minus 1 to the first times 2x. And then I want to set this equal to 0 or undefined. There's no undefines. So I've got 2x plus 4x cubed minus 4x. And I can combine that 2x and minus 4x. Just make sure I multiplied everything out right. This is where it would be really easy for me to make a mistake. Yeah, 4x cubed minus 4x. And I'm going to factor this into 2x and 2x squared minus 1. All right. I have 3 critical numbers on this one, and absolutely all of them are valid because we don't have any x's or y's that, or any x values that couldn't be used. But I'm trying to find the shortest distance. So I have options. I'm actually going to test this one even different than the other problems we did. So I'm going to test this one like we do with absolute max and min. These are our critical numbers, so they have to be maxes and mins. So what I'm actually going to do is I'm just going to test each one of these 3 in the distance equation. So the alternate distance equation was x squared plus x squared minus 1 squared. I'm going to plug in 0 first, and I would get 0 plus negative 1 squared. I'd have a distance of 1. And then I'm going to plug in square root of a half, and that would give me 1/2 plus 1/2 minus 1 squared. Three-fourths? Actually, this is going to be the exact same answer because everything is squared, so it'll all be the exact same info. So when I'm looking at my distances, this one is not the minimum. It might have been a relative min, but it's not the actual min because these two are shorter. So square root of 1/2 and negative square root of 1/2 would be the x values that would give the shortest distance between the parabola and 0, 0. Because I think this said x values. What is the x coordinate? So square root of 1 over 2, and it looks like the positive version wasn't even a choice on the multiple choice. It basically wanted you to pick which one up there it did, though. Okay, I know we only have 7 minutes left. I tried to leave a little time at the end. I realize 7 minutes isn't a little bit of time. Go for it. Go for it. I can. To the problem up here? Oh, because I wrote my answer in a non-correct form. Negative square root of 1/2 is the same thing as negative square root of 1 over square root of 2. So it's negative 1 over square root of 2, and then they rationalized it. So it's negative root. Yeah. Yeah, I wrote my answer in a non-correct format. I get used to that, knowing what the correct answers should look like. And that's my fault. I should do a better job of writing them in a better format. They're both correct. Yep. Yeah, so the positive one, positive square root of 1/2 and negative square root of 1/2 are both minimum distances. But on this multiple choice, you basically were just going to pick all of the correct answers that were there. And so this was the only one that was correct that was shown. If positive was there, you could have chosen both of them. They are tied. Yeah, this was just a question somebody had got wrong and they couldn't figure out how to get it right. And I liked it as an example, so I thought I would keep it and put it up. Okay, I know that was a lot of info to fit in today. Lily, I can certainly help you with your question in a little bit, or I can help you tomorrow, kind of your choice. I would 100% be practicing a lot of these tonight to find out if there's things you have questions on. Now, I don't want to call out people in particular, but I feel like I'm going to have to soon. There are like 10 people who are under 7% in Khan Academy right now. I have a higher percentage in Khan Academy by me going through and finding sample problems to take screenshots of. And that's with me picking random answers. And that made me kind of upset. Like, I don't understand how some of you can't put together the fact that how you do on the homework is how you do on the tests. Even if you're really good at calculus, then you should be smart enough to realize that there are so many different style questions that you would want to look at the different style questions to see where you would get stuck on. There are just way too many people who haven't been working on the homework. And I don't get why you're signing up for a difficult class that's optional. Like, this isn't a required class in any which way. This class is generally for people who are going into things that need calc. So, I mean, like, generally the people in here are because they want to be, not because they have to be. So there's far too many people that haven't been doing homework that need to get on that. All right. Well, either way, thank you guys for coming today. I will be on until 2:15 if you guys have any kind of questions. So it's my open help session here next, which is weird to do right away.